So yeah, good evening, everybody. Thank you for joining us as well this evening for this latest episode of Golang Live. For those of you who don't know, my name is Jake O'Regan. I'm a specialist Golang recruiter at Amicus Recruitment, and we recruit for Golang engineers in the UK, in Germany, and all across Europe on a remote basis as well. So I'm delighted, as always. We've been joined by Oli in the past, and we're delighted to have him back again today. So thank you, Oli. Oli's an experienced Golang professional, done many speaking events, meetups, and been a guest speaker on here before as well. And the episode tonight is called Big Code Bases and Go. So I've been advised it could last around 30 minutes or so this evening, and we'll be answering questions throughout. So if you do have any questions, just please write a little note in the bottom, and I'll interrupt Oli if there's a good chance to do so. But yeah, that's all from me. Without further ado, Oli, over to you.
Okay, thank you. Yeah, it's really nice. And I think I should just share my screen and let's start with the presentation. So I'm adventurous now and do the thing that you shouldn't do and share my whole screen. So this hopefully looks good. I try to make this full screen. And so I want to talk about big code bases and Go. And yeah, currently working for Newstore. Who am I? At least 25 years of professional software development background, almost 20 years of Java before, now 6 years of Go. 4 years I'm co-organizing the Berlin Go meetup. And yeah, now let's try first little Go example. So this is just a simple thing that reads a file, and in Go, every source code file needs to start with a package. So all Go code lives in some sort of package. Here it's the main package that has a special role because you can directly execute the result. And we need some imports. We will see why. And the function main in the main package is the thing that is executed directly from the operating system. And so we want to read a file, and we have a file here, test data, hello.txt. And from the package OS, there's a read file function. So that's why we import this package OS. And that package has up here, instead of main, OS, right? And we get back the content of the file plus any error if there happened to be one. And we check that first, of course. So if there's an error, it's not null. And we would do a log fatal, which you shouldn't do in production, but for such an example, it's nice and simple. And now we have the file content and can do something with it, like just printing it or something. Right? This is one of the simplest Go examples that you can do. And well, it's quite boring, right? I mean, you can read a file in a similar way in probably almost any programming language. I think in Java, it is a bit more complicated when you remember directly because you have multiple readers that you cascade into each other, but otherwise it's more or less the same. And yeah, JavaScript is a bit of an exception because it only offers asynchronous I/O. Right, and you need a callback to handle that, and so on. And yeah, the code, it looks a bit between scripting and a traditional compiled language, so we didn't have to declare that many types all the time, but still a little bit. And yeah, what would be cool instead? So doing everything asynchronous, that would be cool. That's the cool thing about JavaScript on the back end, right, for high scalability. Because it's easier to perform other tasks while waiting for the I/O, right? That's why you do this thing with all the callbacks in JavaScript. And of course, not having a longer garbage collection breaks with quite many milliseconds or even multiple seconds, of course. Java is often quite good there, but for large heaps, so when you have a lot of memory that has to be garbage collected, it can be quite long. So I have heard from companies that have over 100 gigabyte of heap, and which is huge, of course. And Java tends to try not to do garbage collection a lot, and then if it has to, it's a lot of work, and then this can be like multiple seconds where everything is stopped and nothing is going on, and we don't want to have that, to have lower latency, right? And yeah, the trigger is Go is really doing all that automatically behind the scenes. This simple code snippet is actually performing asynchronous I/O, even though it looks like simple synchronous code without any callbacks or anything funny. It is the runtime is doing behind the scenes asynchronous calls. And it would perform other tasks while waiting for the input if there would be anything else, right? So without any callbacks, without reactive libraries or whatever else you have to use in other languages. And of course, the same goes for networking, right? And this is main reason why most of the cloud technologies out there, so like Amazon Cloud and this Prometheus Kubernetes things most people tend to use in production nowadays, are all written in Go. And but you get very low latency and high throughput stuff with it. And so when you have another executable running within such a cloud, you don't feel the overhead from the Go written cloud around it anymore. And that's quite cool, right? And yeah, this is enabled by this, and you get it kind of for free, right? And yeah, in this way, it's very simple, right? You don't have to do a lot of hoop jumping and whatever else you would have to do in C or C++ to achieve something similar. And yeah, other features, programming languages, in general, it's more a cultural thing, right? But layers of abstraction are usually frowned upon. You don't like them. If possible, we try to avoid them and try to do as direct as possible the things we really want to do. And so most of the standard library is only like 1 to 3 calls deep. And I've never had to debug more than 5 calls into dependency. Of course, it depends on what you choose to use as library, but most libraries that are widely used in the Go community are written in the same style, and so they don't have so deep call stacks. And of course, company business software is a bit of a different story, but even there you try to avoid things. Most functions fit on a screen, so this is quite similar to what you do with clean code in the Java world or so. And yeah, even the heart of the runtime system is quite simple. I've seen a talk about that. So the thing that is handling all these Go routines, it's called, where you can do something different behind the scenes while performing input or output. And and all this automatic switching and so on. This is like 2 screens of code, right? It's not the most simple code, of course, but given 1 or 2 hours, you can understand it and could theoretically fix a bug in that within a day or so, right? And it's, hope it's never necessary, but still it is doable, it's accessible enough. And yeah, I've in other dependencies discovered and fixed bugs before myself too, and it's quite doable. You can do this in half an hour often. So, and that's quite good tradition in the Go world, and not something you have to specialize for or whatever, need a special exam or extra expertise. So, but it's just simple enough that this just works. And yeah, now let's talk about what we do in the Go world to structure bigger code bases, right? We have these packages, as I showed you. First was this main package that we were using, and other packages have their own names, of course. And so all Go files in one directory belong to the same package. Generally, there's one small exception for tests, but doesn't matter here. And cyclic dependencies between packages are not allowed. They are prevented by the compiler in the Java world. I had quite some trouble with that. It was very hard to refactor something when you have these cyclic dependencies, and Go simply doesn't allow this at all, right? I know there are sometimes some patterns where you need cyclic dependencies, but cyclic dependencies within a single package are okay. And a single package is not that big. You can still get it into your head relatively quickly. So this works pretty well, I think. And yeah, so packages, of course, shouldn't be too large, right? There are sometimes clever people who think, well, cyclic dependencies and all these things, I don't want to care about it. I just put everything into one package, right? And then, so package, it's a directory, it can have many files, but please don't overdo this, right? And in general, you can have a package structure, of course, so like the directory structure. And so you can have packages with sub-packages and so on. And yeah, the spaghetti cutter tool is an example. It can be used to measure and restrict the size of Go packages. And I don't talk that much about that part today. But I want to instead analyze a small Go project just to get us going, right? And then we can see how this works out for bigger Go projects. So important thing is now, of course, the packages, right? Because this is the thing, the only thing to structure a big code base. And this is it. So yeah, got this open source tool, the spaghetti cutter. I can give you a link out. It's on GitHub. You can find it. We don't want to see errors. Shouldn't do any checks. We want to have some statistics and some documentation. And this service is so this service is a sample project, a relatively small one for a little shop from Arden Labs. Bill Kennedy has written this. don't know if you know him, but he's one of the most famous people in the Go scene and is doing a lot of trainings. If you get the chance to get a training from him, please use it. It's really valuable. And so this is a very nice example of how you can start your own projects, and very well thought through everything. And so this is an example of a good project. It's not too big and it's relatively nicely structured. Right, and we get some statistics and some documentation out of it from this tool. And now let's take a look at what that looks like. So, oh, sorry, it's the wrong one. Why do I have to? Oh, yeah. These are the statistics. Right? We see that there is two main packages, this metrics and the sales API. The API is really the big thing. This is the service that we are really running, and it has 5 direct dependencies like packages it's including and importing, and 18 transitive altogether. And it's not used by anyone because it's the main one, right? And instead it's using the others, right? And you can click through and see all the dependencies it's using and the direct dependencies and so on. And these are all the packages that are inside, and you get a good overview of the project and can get an idea how this is somewhat structured, right? We see here are some business packages. So this is all the business layer, and everything on the up is the application layer, like the HTTP handlers and so on. And so that is on top. And yeah, then there's a foundational layer that doesn't have any sub packages or so, and so we don't see that here. And here, this is the documentation that is automatically generated, where we see what is used by something else. So this is the sales API, and it is using the app services, the handlers from the sales API, of course. And here it's using from the business layer, the authentication system, and also from the business layer, the database. Okay, it's probably injecting this into some other parts. And from the foundation, these are the tools that are used in this project. They are all in the foundation layer. And yeah, there's a key store and logger used. Yeah, logger is a very typical example.
Just got a quick question come through, Ole, from Burke. Thank you very much for your question. Question is, does it provide a visual output, for instance, a dependency graph?
It's not a graph, it's this table.
Okay.
This is the most visual output. There are 2 reasons for this. One is these visual graphs look really nice, but when they grow a bit bigger, it's really hard to work with because you have so many lines that are crossing each other and go through some of the bubbles and so on. It's quite difficult to read. And these tables can grow a bit bigger, and you can still see a structure and understand how things are related to each other. So that's the one reason I'm using this dependency table instead. And the other one is it's way easier to generate, of course. This is just simple markdown, right? This is, and GitHub, GitLab, whatever you use can render this out of the box. I just push this together with the source code, and you can have this in continuous integration as a job running, and then you have always up-to-date documentation for your project. And when you would do something similar with a generating a graph, there are some tools like this dot tool and so on that could do that. But you have way more dependencies, and the graphs are rarely good to look at. When they are small, they are great, but if it's getting a bit bigger, they're usually quite a mess.
Thank you very much.
And so this is, of course, a simple example, right? You can see, okay, it's quite well structured. Right here, a lot of cells are empty, and we see, okay, that some things are used a lot, and like these foundational things, and others are like more shield, are using a lot of dependencies but are not used themselves so much, like this handler. And yeah, this makes quite good sense, and you can get a good overview. But of course, the question is, what happens when you have a bigger project? Right, this table is has a good size here, but if it grows, you have to scroll endlessly on the screen, and it's not so nice to watch and work with it anymore. And so let's just try that and see what you can do with a bigger project. And I chose, for a few reasons, the Prometheus project. So that's the project that most people use in the cloud for collecting metrics, right, from services. And it has an HTTP API where you can see the results and so on. So it's not too exotic compared to what we usually do ourselves as programmers, right? Most Go developers nowadays do HTTP APIs themselves, right? Like usually for business software, maybe something fintech or so, but usually it's some sort of web API. And Prometheus has something like that. And Prometheus, I tell you, it's of course one of the biggest Go projects that you can find. It's open source, and it's always showing the wrong window, sorry. And so it's one of the biggest, right? I show you here the package statistics, and this is the main executable, right? The Prometheus executable itself. There's some tool next to it. That's not that important for us now. And then you have a lot of packages going with it, right? There's some config, and discovery is a big thing, right? It has to discover the metrics from many sources. And so this is a huge part of the code base. Then there are some examples, which is not that important for us now. Then some other package interesting is this time series database. This is where it stores all the metrics that it scraped from the services. And this is a good chunk here too. And yeah, so let's see if we can still find a bit of structure in here. And when we see here are two score values at the end in this table, max score and min score, this means how well one package is shielding other packages away. So how well it is encapsulating something else. And so the packages with a high score are good candidates for keeping something for using a subtable. That's what we want to do and used as a submodule. And so when we look at this dependency table now, usually, as I said, right, you have to scroll quite a lot, and this is what happens here, right? When you have all the dependencies here, this is quite a lot, and it's not that nice to read anymore, especially all these discovery things. It's sorted by name, but still it's not that great to read. And yeah, you have a very long list too. It's not nice to get an overview, right? And what you can do is you can build subtables, right? I can show this feature quickly. So what you can do the same as before, call the spaghetti cutter, say, okay, I don't want errors, I want statistics, documentation, but now not only for the main, but you also want subtables for everything discovery and everything underneath, and this time series database. And so you have two big blocks that you kind of extract that. And when you do that, you get something. Oh, sorry, this is a bit annoying, but don't know how to do about it. So what we get out now is that from all the discovery things, we have only like 4 columns left. And so this is way easier to grasp now than this long table where you have like only discovery things here, right? This is still discovery, 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 discovery. There is something else. So yeah, so we have like 20 times discovery, right? And this is all not used by the rest of the system so much, right? It's relatively well encapsulated. And so what we can do here is get a bit of an overview of how the rest of the system works. And if we are interested in this discovery thing, we can just click on here, and then that link to a subtool that contains all the discovery things. So there we see, okay, that's this discovery install that seems to install the discovery that is chosen. And so this has everything else more or less as dependency. And yeah, then there are 1 or 2 others that depend on some things. But this is everything depending on discovery, the main package maybe of it, but the parent package, right? And so there are probably some interfaces defined, and there are some types that are used by all the discovery methods here. And then these discovery methods can be installed by this discovery install. And yeah, that's and so when something somewhat modularized, you can get a good overview and can have a quite big code base and still understand it pretty well. So similar here, this time series database shielded that nicely with a lot of packages from that. We take a closer look at it, we see that it is used by one thing a lot. I think it's storage or something. Yeah, the storage package. And this would be a candidate if that would shield this time series database even better way. Then we could have a subtable just for the storage. And then this would be really great again, right? Then we would lose quite some columns here again and would get a better overview. So I would probably try and take a look if this would be possible to make the API of the storage package a bit nicer and then share the time series database a bit away from the rest of the system. Yeah, but that's it. So you can get quite a good overview and see, okay, where should I work a bit better to get better modularization, and well, it's already quite great and easy to understand. And that helps a lot, of course, when you dive into a new code base, you get a good idea how good or bad the code base is quickly. And yeah, so let's stop here.
Very good.
Do we have any
questions? I was just going to say, if anyone has any questions, and now's the time to ask up, feel free. Just so everybody knows, this is recorded, so you can watch it anytime. Anybody who's joined tonight, and there's quite a few of you, will receive a copy of the recording. So if there's anything that you maybe missed in the first few minutes or anything you wanted to double check, then obviously, there's going to be opportunities to rewatch it. And obviously myself and Ollie were happy to, if something comes up in a later date, maybe tomorrow or something that you wanted to ask, then we're available to answer any questions then as well. But I'll give it another 20 seconds or so. But thank you, Ollie, for being a guest again tonight. It was really good, a really good turnout from everybody who's joined as well. So thank you for everybody joining. It doesn't look like there's any questions coming through, Ollie, so we might just have to call it there. But no, thank you again, everybody, for joining, and thank you, Ollie. That was a really great talk again. And yeah, I'll tune in for the next ones, guys. Keep a lookout, and please follow Ollie on LinkedIn. There's always got things going on as well, and the Berlin meetups.
Yeah, sure. Yeah, please join the Berlin Go meetup if you like this, right? We have more interesting talks every month usually. So
great stuff.
Welcome for that.
Excellent. No, well, yeah, guys, have a great evening. Thanks very much, and we'll see you again.
Yeah,
take care. Bye-bye.
Bye.